Good morning. We continue with reactions of aldehydes and ketones. Next is reactions of aldehydes and ketones with amines. Reaction with amines. Okay, RNH2. The product name is imine. The product name is known as imine, which is also known as Schiff's base. Schiff's base. Okay. Example. So next is the reactions of aldehydes and ketones with amines. Look at some examples of reaction with amines. Acetaldehyde CH3C double bond OH react with methyl amide CH3NH2. We can write CH3NH2. So what will be eliminated? H2 is eliminating, and we get look at it here, CH3 C, this H, CH, double bond, N, CH3, what will be eliminated? Minus H2O, and what we get? Look at it here, in the nitrogen there is a methyl group, so the name is N, methyl. In N there is a methyl group, N, methyl, 2-carbon alkane is ethane. Replace E by imine, imine. Replace E by imine. So what is the name of this compound? Look at it here. N-methyl. In nitrogen there is a methyl group. So N-methyl, 2-carbon alkane, ethane. Replace E by imine. So N-methyl ethylamine. N-methyl ethylamine. This is a Schiff's base. Another example. Look at here, we take benzaldehyde, okay, CHO, C double bond OH, benzaldehyde react with methyl amine, CH3NH2, methyl amine, so H2 is eliminating, and what we get, look at it here, okay, here it is like this, and here it is CH, and double bond N CH3. The name of the compound, look at here again, N-methyl. This is known as this one is known as benzylamine. N methyl benzylamine. Let us go through some other examples. So another example is we take again acetaldehyde CH3C double bond OH, and we take aromatic amine, that means ring NH2. What is this compound? This is aniline. So aniline, then what we get? So look at it here, H2O is eliminating, and we get a compound like this, CH3CH double bond N, and again what is here? Here is a ring. What is the name of this compound? N phenyl group. Okay, N phenyl, N phenyl again. Ethane is E is replacing by imine. So N phenyl ethylamine. This is also a Schiff's base. Another example, if we take a ketone, CH3, so okay, CH2, C double bond O, CH2, CH3. What is the name of this ketone? How many carbon atoms? 1, 2, 3, 4, 5. 5 carbon ketone, pentanone. Okay, so you can see that pentanone, actually it is pentanone or pentanone. But you can see that 1, 2, 3. In the third carbon, the CO group is there. So what is that? Pentan 3 on. Okay, pentan 3 on. Pentan 3 on. Pentan 1, 2, 3. 1, 2, 3. So what is the name of the compound? Pentan 3 on. Pentan 3 on react with okay, methylamine CH3 NH2 CH3 NH2. What will be eliminated? H2 is eliminating. And what we get? CH3 CH2 the double bond N, and then it's also CH2 CH3, and it is CH3. This is another Schiff's base. Okay. Okay, if you want, we will take few more examples. Let us consider a few more examples for reaction with amines. Next is if you take acetophenol. What do you mean by acetophenol? That means C double bond of CH3. Okay, CH ring C double bond of CH3. This is known as acetophenol. Acetophenol react with ethyl amine CH3 CH2 NH2. What is this one? Ethyl amine, again H2 is eliminating, and we get ring is here, then CH double bond N CH2 CH3. We get this Schiff's base, and similarly you can take any example in order to get a Schiff's base. That means keep it in mind, aldehyde or ketone react with amines will form Schiff's base. Clear? Okay. Next is reduction of aldehydes and ketones. Another important reaction of aldehydes and ketones, that is reduction of aldehydes and ketones. Reduction of aldehydes and ketones. Okay, first one, reduction to alkane. That means aldehyde and ketone is reduced into alkane. That means the CO group will be converted to CH2. CO group will be converted to CH2. Then we get alkane. So we are discussing reduction of aldehydes and ketones. Aldehydes and ketones will give two types of reduction reaction. One is reduction to alkane, and the second one, as we know, reduction to alcohols. So first we discuss what is that reduction of aldehydes and ketones into alkanes. Okay, out of that there are two types of reduction reaction into alkanes. First one is Clemmensen reduction. Clemmensen reduction. Okay, Clemmensen reduction. What do you mean by Clemmensen reduction? This is Clemmensen reduction is the reduction of aldehydes and ketones. Into what? Into alkane using zinc amalgam. That means zinc and zinc coupled with Hg, zinc amalgam, zinc and Hg, which is known as zinc amalgam. So using zinc amalgam and concentrated HCl. This reduction is known as Clemmensen reduction. So when aldehyde and ketone is reduced with zinc amalgam and concentrated HCl, we get alkane. That type of reduction reaction is known as Clemmensen reduction. So keep it in mind, study. Clemmensen reduction is the reduction of aldehydes and ketones into alkane using zinc amalgam and concentrated HCl. So let us go through some examples. Acetaldehyde CH3 C double bond of H. Acetaldehyde is reduced with that means for H reduction. Okay, reduced with zinc amalgam ZnHg and concentrated HCl. Okay, and of course we are heating. Okay, we heat, concentrated HCl. What will get? CO group is reduced to CH2. CO group is reduced to CH2. So what will we get? CH2H, CH3. That means we get CH3, we get ethane. Clear? Another example, if we take a ketone, CH3, C double bond of CH3, acetone, acetone reduced with 4H reduced with zinc amalgam, zinc Hg and concentrated HCl followed by heating. What we get? CH3. CO group is reduced to CH2 and what we get? CH3. CH2. CH3 we get propane. We get propane. Another example, if you take what is this one? Cyclohexanone. Cyclohexanone. This is a ketone. What is this one? Cyclohexanone. Cyclohexanone. On a reduction with okay, for H again same thing I am writing. Zinc amalgam ZnHg HCl heat. What will get? The CO group is reduced to CH2. So what is that? The CO group is reduced to CH2. That means you get simply a ring because now here it is CH2. What do you mean by here? What is here? CH2. CHH. CH2. CO group is reduced to CH2. This is cyclohexanone. Hexanone. Cyclohexanone. Hexanone is reduced to cyclohexane. Cyclohexane. Okay, this is cyclohexane. This is cyclohexanone. Hexanone. This is cyclohexanone. Cyclohexanone is reduced to cyclohexane. So when we use zinc amalgam and concentrated HCl for reduction, that type of reduction is known as Clemmensen reduction. Okay, and we get alkane. Another reduction again we get alkane. That reduction is known as Wolff-Kishner reduction. Wolff-Kishner reduction. Wolff-Kishner reduction. By Wolff-Kishner reduction also the aldehyde and ketone will be converted to alkane, but the reducing agent is different. Okay, let us go through Wolff-Kishner reduction. So when heated with hydrazine. What do you mean by hydrazine? What is the formula? NH2 hydrazine that we have studied. When heated with hydrazine and KOH at 140 to 200 degrees Celsius in presence of diethylene glycol, diethylene glycol, DEG, diethylene glycol, or dimethyl sulfoxide, dimethyl sulfoxide, which is also known as DMSO, dimethyl sulfoxide. What we get? Aldehydes and ketones will be reduced to alkane. Okay, when heated with the hydrazine and KOH at 140 to 200 degrees Celsius in presence of diethylene glycol, DEG, or dimethyl sulfoxide, aldehydes and ketones, aldehydes and ketones will be reduced to alkane. This reduction is known as Wolff-Kishner reduction. So keep it in mind, in Wolff-Kishner reduction, the reducing agent is what is that? Hydrazine KOH at 140 to 200 degrees Celsius in presence of diethylene glycol or dimethyl sulfoxide. Okay, let us go through some examples. Okay, same examples we can write. There is no difference between Clemmensen reduction and Wolff-Kishner reduction. Only the difference is the reducing agents are different. Okay, so again CH3, C double bond O H acetaldehyde when reduced with hydrazine NH2 KOH at 140 to 200 degrees Celsius in presence of DEG or DMS, so dimethyl sulfoxide. What we get? The CO group is reduced to CH2, so what we get? CH3, CH. Clear? Another example, same example you can take, or another example I take benzophenone. What do you mean by benzophenone? Ring, CO ring. Okay, this is benzophenone. Benzophenone. Any example you can take benzophenone. Okay, reduced with again same condition. You write the same condition here. NH2, NH2, KOH 140, 200 degree, DEG or DMSO. What will happen? CO group is reduced to CH2. So what we get? We get, look at it here. Here will be CH2. Again, it will be the clear. So this is the reduction of aldehydes and ketones into alkane. There are two types of reduction: Clemmensen reduction and Wolff-Kishner reduction. In Clemmensen reduction, the reducing agent is zinc amalgam and concentrated HCl. But in Wolff-Kishner reduction, the reducing agent is hydrogen KOH in presence of DMSO or DEG at a temperature of 140 to 200 degree Celsius. Okay, this is the first class of reduction of aldehydes and ketones. That means aldehydes and ketones into alkane. Next is reduction of aldehydes and ketones into alcohols. That we will continue in the next class. Thank you.